Hi guys, welcome back to the channel. Yes, I fell off of my schedule unfortunately because of end of semester and everything, but I should be able to be more organized, right? Yes, and again school me for that. But today I am back with another AutoCAD video, and today we're going to be talking about oblique projection. So guys, if you want to see that, stay tuned for the video. CSEC students, you may talk to, especially Uno. Yes, let's go. With jobs. That the ratio of the first part of the video was the incorrect ratio for YouTube, so it's not wide enough. So I'm very sorry, but I do believe it's not that bad. You can still see. So let's continue the video. So let's say we have this little box right here. Looking at it like this, we cannot see the different sides of the box. Now, you would say this is probably like a 2D object because looking at it is a 3D object. But looking at it like this, we cannot see the rest of the object. What oblique projection allows us to do is to see the different sides and faces of the object. Let's get to another example. Now, there are two different types of oblique projection. We have Cavalier projection, which is right here. This one, hopefully you can see it. And we have cabinet projection, which is this one. Now, what I was saying about you being able to see all the different faces of the object is like this, right? Now, you have the face, right? And then you have all these lines going at a 45-degree angle. So that's the other thing. In oblique projection, we do not use a 30-degree angle and stuff like that. If we are going to do an oblique projection, you're going to need your 45 only, your 45-degree set square only. Because we use 45 degrees line, which is going in this direction. Then we're going to need our horizontal lines, which we would call 180 degrees, and then our vertical lines, which would be 90 degrees. Okay, so this is our Cavalier projection. It's upside down. Cavalier projection. So in this, we have the face at first. So this is what you're going to draw first. I'm going to demonstrate to you in AutoCAD. But this is what you would draw first, the face. And then from all the corners, you would draw your 45-degree lines to whatever length it tells you to do it. Now, with the Cavalier projection, you have the full length of the 45-degree line. Now, to the cabinet projection, if you realize it is much shorter, it is much smaller, that is because we would half all the 45-degree lines. So you would have your face as normal, right? You would have right here as normal, as you can see, right here and over here. The two faces are the same. The only difference is this 45-degree lines right here, they're 60 millimeters. However, when you get over this side, which is the cabinet projection, it says it is 30 millimeters. So all you do is just cut it in half. So half of 60 is 30. And then when we get to, the end, we would just connect these with our vertical only and horizontal line. So if I should erase this line right here, this vertical line, obviously you will see the connection there would be vertical. And if I should erase this one right here, obviously you would see that the only connection is horizontal. So that's the only way you should be connecting your, oh, I'm sweating, wow. That's the only way that you should be connecting your lines with a vertical or horizontal line. Now let's go to AutoCAD and get a better understanding of this from an isometric drawing. So we're going to be doing oblique drawings from isometric drawings. Let's go. So as you can see here, we have our joint space where we're going to do the oblique projection, and we're going to be using this isometric joint that we see right here, and it was the same one in the beginning of the video. And yes, the ones in the video, I did those joints. Thank you very much. Thank you. Thank you. Give me a hand. Give me a hand. Okay, so let's begin. No, I have changed my line weight and have my color in black since the joint space background is white. Oh guys, if you also want to know how to do some tips and tricks in AutoCAD, you can start watching my shorts. I've already uploaded one with a special little tip and trick in AutoCAD. So I will start uploading shorts for you guys pretty soon. So let us begin. We're going to select line, L, enter. That's the shortcut. And we're going to draw the front face of the object. So right here, the front face, right. Now just go down 25. Now if you see that my line is a little bit wobbly, we want straight clean line. So what we're going to do, we're going to go down to the bottom tab, and we're going to turn on our auto mode, right? And we're going to select our 25 line. Now going across, we see 60. Just like on the photo, we can continue because we're having clean straight lines and 60. Oh, also, my computer 0 is not working, so I have to use the online screen. The keyboard on screen. So yes, 60, enter. Then we're going to go up. No, we're going to do a little math here. We see on the drawing, let me escape. We see on the drawing that this little line right here is 10, and we don't know the one right here because it did not give us a measurement. Oh, actually it did not give us a measurement. 20 is for a different line. Okay, so it did not give us a measurement, but we know that one line here is 10 and the other over here is 25. So what we can do is minus 10 from 25 to get the line right here. So 10 from 25 is 15. Not too bad at math, huh? Okay. Now we're going to select back the corner that we were at, and going up, we're going to say 15. Enter. Going across, we see right here it says 20, so we can just select 20, enter, and going up again. Oh, undo. Don't know what happened there. 20. Sometimes I forgot that my 0 doesn't work. 20, enter. Going up again, we have 10, enter, and we can just go ahead and connect, right? Don't have to put in any measurement, you can just connect. So that is the face of our drawing, right? Now we're going to draw our 45-degree line. So we're going to go down here where we see this little clock, and it's called polar tracking. We're just going to select the drop down. Now we see various angles, but we know the angle that we want, so we're just going to click on 45. For this drawing that I'm doing right now, we're doing Cavalier. So just like in the beginning of the video, I did say that with Cavalier, you just do the complete line, and with Cabinet, that's where you would cut the line in half, the 45-degree line. So let's go. L, enter. From every corner, so we have 1, 2, 3, 4, 5 corners. From all of these corners, we're going to draw 45 degree lines that are going to be 60 millimeter. Again, that's not working. And we don't have to draw lines continuously. What we are going to do is just select this line because my zero is not working and that's going to take a long length of time. So we can just select this one line and copy it, go to the endpoint right here, and we're just going to go and select our rest of corners. And just like that, we have all our 45-degree lines. Let's zoom out a little, as you can see. Now, again, going back to the beginning of the video, remember where I say that when you're connecting your points, it should either be vertical or horizontal. None of the connection lines or points should be at an angle. Let me show you what I mean. L, enter. If I select this point and I'm going here, if you realize it says 0 degrees at 40, so the length of the line is 40 millimeters, but the degree is 0. Why? Because it is a straight line. So we're just going to select that. Now we're going to go down to the next point. Realize it is at a 90 degree. So vertical lines and horizontal lines only are supposed to be used to connect your point. Now, if you realize, let me calculate something here. Let me shorten this a little bit. All right. Now, if you realize that you want to connect your line and you select a point and you realize the point is going down here, better yet, let me use the one over here as the example. If you select this and you're going across, let's say you go across and you realize that it's not connecting. As you see, 180 degrees, that's a straight line going across, but it's not connecting with the line that you want it to connect to. You're supposed to go and connect with this line. Boom. That's an angle. We do not want this. This is not what we want, okay? So let's continue. Undo, 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 undo. One. Okay, let's just. Some of my keys are not working, guys. I have no idea why, but that's okay. The Lord will fix it. But let's just copy this back. It's fine. Right. So we are going to go back and connect our lines again. From this point, going down should be 90 degrees. Going across again should be 0 or 180. And going down again, this should be 90. And that is it for our Cavalier oblique projection. Now, let's just quickly, this is a simple isometric drawing. In our next video, I'll do a more complex one. So I'm going to post this video and then I'm going to get back on my schedule with the next video. My schedule was every other Saturday. So this Saturday, I will post the more complex one. And then, after this Saturday, you won't be getting a video, but, the other Saturday, you will. So I post every other Saturday, or I should be posting every other Saturday. But let's get to work. The same procedure. So first we're going to end up drawing the face, just the face of the object. So going down 25 millimeters, going across 60 millimeters, going up. Let me put this on. Going up, we have 15. Across again to the left, we have 20. Enter. Going up, we have 10. Enter. And then we just connect that. Enter. Now let's just move this a bit because maybe the 45-degree angle lines are going to my recording stop. So I was saying I was going to move this because maybe it's going to touch the other drawing a little bit. So let's just move this over here and work with it there. So again, we're going to have line, and from all our points, we're going to draw our 45-degree line, but for the cabinet oblique projection, these lines are going to be half the size of the isometric drawing. So it's still on 45. It's going to be half the size. So the full size, let me zoom. The full size here, full length of the line here is 60 millimeters. Half of 60 is 30. So what we're going to do, we're going to go 30, 30. So if you realize it is shorter than the first one that we did. So we're just going to copy this line, because all the lines that we want at every corner should also be 30 millimeters. So let's just copy to every corner. All right. And then again, all you got to do now is connect it. Vertical and horizontal lines only should be collecting your points. So once you go from one point to another, it should either be a 90-degree line, a 180-degree line, or a 0-degree line. And that is it for cabinet and Cavalier projection.